Hello, James Flotten here with the Minnesota Space Grant Consortium. I'd like to tell you a little bit about Neulog modules. These are standalone sensor modules. This one happens to say magnetic field. Here's one that says sound. For making measurements, in my case, I mostly use these on stratospheric balloon flights. They're very simple to use. You have to set up how often they take data, and of course select the sensors. You can plug them together so you can fly many sensors, up to 5, on a single battery. So this is approximately what it would look like to use a Neulog sensor chain. Start with a battery, plug in this case I plug in the magnetic field sensor. Notice that it flashes, that just tells me that it has power. Let me plug in the sound sensor. That will also flash. They are in fact already running, but they're not yet recording. So they have a button on them, but the button is not turn on, but rather the button is remember what you are doing while you're already running. The reason that's important to remember is the battery will deplete right now, even though I'm not really using them yet because I haven't hit record. So here's the record button. There it is. And if I press record, this one is set to take data once a second, and this one is set to take data once a second. So notice each of them is flashing, in this case once a second. If that light never flashes, it's not running properly, and if that light seems to be on steadily, that means it's running really, really fast, and that may not be what you intended. So make sure the lights flash at the rate you expect. For a stratospheric balloon flight, a typical setup would be take data once a second for multiple hours, maybe 5 hours. So that's what it looks like to use them, and here's what a sensor pack might look like. So this one is one battery and 2 sensors. Here's one that I flew recently. It actually is one battery and 5 sensors. And what I've done here to keep it small enough to fit into my payload box is I took the 2 sensors and then I went around the corner with a cable, and then I have 3 more sensors on the back side. These happen to be acceleration sensors. They will measure acceleration force, in fact, in 3 axes, but you can only record one axis. So if you have 3 of them in a row and you choose x-axis for one, y-axis for one, z-axis for one, 3 of them in a row will allow you to measure acceleration, force, in 3 different directions. And on this side I have pressure and wide range temperature. Pressure is my favorite sensor actually, and the reason is as soon as the pressure changes I know that I'm flying, and when the pressure stops going down and starts coming up I know that I've burst and I'm on my way back to the ground. And then when the pressure steadies again, I know that I've hit the ground. Temperature, wide range temperature, in fact, with this long sensor cable can stick outside of my payload box and monitor what's going on in the atmosphere. But that actually doesn't change as promptly as you might expect, and so I can't exactly tell when I start to fly, and I can't exactly tell when I start to burst on the wide range temperature sensor. On the other end, if that's what a pack looks like, here's how that pack might fit into a box. So here's a box that actually has already flown, and inside of the box, up here, I can see a sensor pack. It has different sensors than that one, but this is approximately how it could be mounted. It's strapped into the box, it's held in place with a zip tie, which has now been cut, and in fact, since I can't see the battery, apparently the battery's on the back side, and I would want to set this up so that I could plug in the battery at the very last minute, and then press the buttons, and then put it in the box and strap it down, because I can't even reach the buttons on the back side either. So you have to think a little bit about how to implement it in your box and make sure that it's serviceable, it's reachable, all the things you need. And the battery should be out and charged and fully charged right up to the last minute, because as soon as you plug it into the sensors, it starts to deplete the battery. To charge the battery, you'll need a mini USB cable. So here's the business end of a mini USB cable. Careful, it's not a micro USB cable, it's a mini cable. And to charge the battery, you plug it into the end of the battery, and then the light will come on. One of the things I don't care for on this system is the light stays on forever. It does not tell you is the battery fully charged, is it discharged. So I usually just plug these in overnight, and by the morning they're ready to go, but I don't know at any given moment are they close to fully charged or are they close to fully depleted. Similarly, I don't really care for the fact that it starts to expend the battery as soon as you plug it in. Just remember, the button you press is not turn this thing on. The button you press is start the recording. It's already on. One of the sensors that you can tell that with most obviously is the motion detector. So the motion detector actually sends out some sound, and then it bounces off things, and it notices when it comes back, and it tells you approximately how far away that thing was. It only works for up to a few feet. Um, but as soon as you plug it into a battery, you start hearing the clicking sound. In other words, you know that it's running, you just haven't started the recording yet. Let me show you one more implementation in a box. Here's a rather different box, but this particular box, actually, if I open up the top and then I pull open the front side, I can see several Neulog modules. There they are. This happens to be ultraviolet A, ultraviolet B, and visible light. And since these are light detectors, they need to stick out the side. So notice that they're out the side here, and I've had to cut a hole in the side of the box for them to reach. Oh, you'll also notice that there's no battery on this chain. Well, that's because I have this cable, and this cable goes around the corner to the battery, which is strapped to the side of the box over there, along with a pressure and a temperature sensor. So that's a chain of 5, and I had to think carefully about how to build the box to make sure that they would face in the right direction. I want them to face toward the sun, and this was flown in the winter time, so the sun was at a low angle. And so this box flew this way, the Neulog sensors faced that way, and they sometimes saw the sun. And then when it turned around, they sometimes didn't see the sun. So not only could I monitor how much sunlight I got in different ranges, I could also tell something about how the vehicle was performing, because sometimes it was facing away and sometimes it was facing toward the sun. And I could understand its rotation. That was sort of a side benefit of mounting it that way. So let me just talk through some of the sensors that I have available. The company has many sensors, not all of which are suitable for stratospheric ballooning, and some of which ought to be and don't work. Here, for instance, is a current detector. So in other words, you'd have to wire this up to force current to go through it. Here is a voltage detector. This could be used to, for instance, monitor the voltage on a solar panel or something like that. The current could be used to monitor the current produced by a solar panel. Here's a resistance detector. So if you have a resistor which you think is temperature dependent, or you're curious, you could just watch its resistance during a flight and, of course, monitor the temperature separately. I have a Geiger counter. So the Geiger counter has the module that looks normal, but then it has a cable that goes out to a sort of a substantial Geiger-Müller tube. Okay, so that will take some mounting thought. I also mentioned magnetic field and sound already. I mentioned motion detector. I have a variety of other thermometers. So this is the wide range temperature thermometer with this long cable on it, which actually can go. This is a thermocouple, so it actually can go to very, very low temperatures. This is the most appropriate one for external temperatures during a balloon flight. On the other hand, the company also sells their standard thermometer. And so although the standard thermometer is maybe appropriate for a chemistry experiment, I don't care for it too much because the thermometer part is so huge and so long, and I suspect the sensitive part is at the very tip, but it's got this very long stainless steel piece, and so if this is at one temperature and this is at one temperature, I'm not quite sure what answer you would get. I don't use these very much unless I'm trying to measure internal temperature of something rather large, large as in several inches in size for sure. Here is a surface, called a surface thermometer, which basically has a very specific small tip. So this could be used to touch something. An application of this might be if I have a battery, I don't want the battery to get too cold, and I have a heater on the battery, and then the idea is I touch this to the battery, and when I notice it getting too cold, I turn on the heater and I try to heat it back up again. So that might have use, but the range of this thermometer is not sufficient for the very cold temperatures you notice in a stratospheric balloon flight. I wouldn't use that outside of the box, but possibly inside the box. And here's an infrared thermometer, so presumably this can point at things and try to understand their temperature at a distance. I'm not really sure you can do this at a kilometers or miles distance, as might be the case on a flight, but it's available from the company. They also sell things like relative humidity sensors. I've tried them. They really don't work well on balloon flights. So anyway, in a given balloon flight, or in a given payload, at least my application again, you would have one battery and up to 5 sensors. And if you don't want a chain that's 5 sensors plus one battery, rather long, that would be twice as long as this, way up to here, then you can go around a corner with a cable. In fact, if you're using the magnetic field sensor, which measures magnetic field but only in one axis, then what you would really want to do if you wanted to get magnetic field in 3 axes is take this one and mount it and use a cable to this one and mount it, and use a cable to this one and mount it. So in other words, you'd use three of these things perpendicular to each other physically in the box and use cables to help you make that connection. Or if you need to look outside of the box with a light sensor, you might use a cable to allow you to have the battery fixed to the box in one place, and then the cable will go to the light sensor, which is pointing in an appropriate direction, perhaps in a different part of the box. Let me show you a little bit about what the software looks like. So I haven't talked to you about how to attach these sensors to a computer at all yet, but I need to do so. And that uses what's called a USB module. So this particular module looks very much like the other ones, but this doesn't fly. This is only a connection to a computer module. That's what this is for. So you'll need a mini USB cable. So it's mini on this end, and then it's a standard USB on this end. You'll need a computer. The software is free, but you need a computer that has a USB on it to make this work. And so in this particular case, what I'm going to do is I'm going to plug in the cable here, just like I use the same cable for charging the batteries. I'm going to plug this into my computer, and let me just show you what sensor I'm going to play with just for a moment. It's the motion sensor. So the idea is, as things are farther away from it or closer to it, it will draw a graph in real time, and it will write down data, if I tell it just to record the data, of how far away it thinks something is based on its preconceived notion about what is the speed of sound. It turns out the speed of sound actually varies as you do a balloon flight, so you might be able to use something like this to measure the speed of sound, but I'm just doing a standard motion experiment. So what I'm doing is I'm plugging the motion detector into the USB. I'll plug the USB into my the USB module, and then here's the cable. I plugged it into my computer. And now let me switch over to share my screen and show you what that looks like when I run the software. So here we go, share screen. Here's my Neulog software. This is free download, Neulog, Neulog. So I'm running version 3.7.96. That might not even be the most current version, but seems to work for me. It'll open two windows, the second of which will show information about the sensors that are attached. So right now it says there's a motion sensor attached. And let's see if I can, this will be all right. Not so great. One moment, I'm just trying to move this window. Well, okay, I'm struggling with my zoom commands here, which always get in the way. Okay, so right now this thing is noticing the ceiling, frankly, because I'm holding it pointing to up, and now that I got closer to the ceiling, it thinks the ceiling is closer, and if I get closer, it thinks it's closer. So in other words, it's drawing a live picture, and it's clicking. I can just barely hear that. And if I were to hold my hand above it, I can have it show something that's rather close to it. Notice that the scale, the vertical scale here is in meters. So perhaps the ceiling is, a bit over a meter away from it right now, and if I hold it lower down, the ceiling appears to be farther from it. So this is approximately what it would look like if you're using it in tethered mode. In other words, you're tied to the computer through a USB module. And to run an experiment, well, first of all, let me just click on the sensor here, and it'll tell me things like what is the maximum range you want to be able to watch, how long do you want to run your experiment, how fast do you want to run your experiment. And so this one right now is set to run an experiment for 10 seconds only, 50 times a second. That's not improper for a ground-based experiment that is done in 10 seconds. It's not at all appropriate for a stratospheric flight, okay? But if that's the setting, and notice it says ID number 1. It turns out if you plug in multiple sensors of the same type, they each need a different ID. So the way to change the ID, that's important. If you have like 3 magnetometer sensors, you'd go to Tools, you'd go to Set ID, and I could say, change the ID to number 2, Set Sensor ID. Okay, and so now it has set it, and if I go back, there it is. Now it says ID number 2. So in the case of 3 magnetometer sensors, you'd need them to be like ID 1, ID 2, ID 3. So the system knows who it's talking to or who it's hearing from. Okay, so here we go. Let's say I run an experiment. So when I run the experiment for 10 seconds, 50 times a second, I hit record. And it's going to show me on the graph, and so the ceiling is 1.2 meters away, and then I put my hand in the way, and so my hand now is only a few centimeters away, and now it looks back at the ceiling, and it's 1.2 minus a little bit, meters away. So there is the experiment. It's finished. And if I have this data, I could export it. Either I could export that graph, or I could export the numbers in a CSV format. Okay. If I go back, I could ask it load experiment, and it says, oh, in my memory, I have two different experiments. Here's an older experiment, number 2. Here's the most recent one. If I say load the older experiment, there it is. That looks different. That's not the experiment we just did. That was short range, farther, short, farther. Okay, that was something I did earlier. And then I can go back and I can say load experiment number 1. It always assumes you want to load the most recent experiment. And here's the most recent experiment that we just did. You know, this is the ceiling, and then this is my hand, and this is the ceiling again. So the data is available, and what it will do is it will save the data up to 5 experiments, I believe. And typically, for a balloon flight at least, you would have a sensor pack, and you would get all the experiments, and you just load the most recent one and look at them, either individually, or you can superpose the graphs, although the graphs get kind of hard to read if you superpose them. So in the case of an actual stratospheric flight, here's what it might look like. So first of all, I do need the USB. And let's say on my flight I want to fly a long wide range temperature sensor. And I'm plugging that in. So notice the sensor will change on the screen. It will switch, I believe, I hope. If it doesn't, I will reload the software. But anyway, so a wide range temperature sensor, and let's see, I put on a pressure sensor, and I'm going to put on a magnetic field detector. Okay, so now I have these 3 things. They're all plugged in. It looks like this is not coming up live, so here's what I need to do, apparently. I need to, one moment, I need to hide the floating controls. I need to get rid of the floating controls because they're preventing me from seeing the top of my window. Yes, there we go. I'm just going to close Neulog and run it over again. And so hopefully now it will open up and it will show me that there are 3 new sensors on: a wide range temperature, a pressure, and a magnetic field. I was thinking I could hot swap, and apparently not. So there they are: wide range temperature, magnetic field, pressure. And if I were to suck on the pressure sensor, let me try that. This number should go down as I'm sucking on the pressure sensor. Here we go. There it is. I kissed it, and it managed to get down from 98 to about 60, and then it popped back up again. I can see that here. In the case of the magnetic field sensor, if I rotate it in space, since it's measuring the magnetic field in some specific direction, the number, the middle number here, is changing from 0.1 to, let me just rotate it, less than 0.1 to more than 0.1. So in other words, that's sensitive to the magnetic field in the direction that the sensor is pointing, but it's the Earth's magnetic field. Right now, it looks like I'm pointing almost along the Earth's magnetic field, so the thing is well under 0.1. And then the wide range temperature sensor, which is giving me 21.5 Celsius. You can change the units if you want. Let me touch that with my finger. It's up to 30, it's up to 31, it's up to 30, come on, come on, come on. I'm trying to get it up to 32. There we go, okay. So let me show you. Here's the wide range temperature, and I could change this from Celsius to Fahrenheit if I prefer. And in fact, this is set for 5 hours at once per second. That's sort of a classic stratospheric ballooning setup. Here's the magnetic field. It's also set for 5 hours once per second. And in this case, you don't have any options. Millitesla, that's what it's going to measure in. It's assuming it's going to be a Earth's magnetic field sort of thing, not necessarily a strong magnet thing. And then here's the pressure. In this case, I can measure it in kilopascal, pounds per square inch, or bar, or atmospheres. Kilopascal is kind of handy. The number then is in the vicinity of 100 kilopascal on the surface of the Earth and goes down close to 0, in fact, when you get to the peak of a stratospheric balloon flight. 5 hours once per second. That's the key. 5 hours once per second. There's no accept button, so as soon as you click it, it is immediate. And now that I have set up the sensors, here's what I'm going to do. I'm going to stop sharing. I'm going to disconnect. So I've set the sensors. They're ready now for a balloon flight. I take off the USB, and then when it's time for the flight, I add a battery. The battery, these things plug together on either side with the exception of the battery. The battery only plugs on one side. So the battery has to be on the end, and it has to be on a specific end. It has to be on the, well, as you can see it, on the right-hand side of your chain when you're facing things this way. So when I add the battery, notice the things flash. That tells me that they have power, but I haven't yet started the recording. And so what you really want to do to start the recording in this case is see if you can press all these buttons at exactly the same time so that you start. And you should write down what time that was because there's no real-time clock on this, just all relative time. So let me just see if I can press these at approximately all at the same time. Here we go. And I got two of them running. I didn't get this one running. Too bad. I missed it. Okay, so the record from this one will be a couple seconds later than the records from the other ones. Usually that's not a big deal. Again, the pressure sensor will tell me exactly when I start to fly and exactly when I burst and exactly when I land. The magnetic field sensor will tell me what it knows, and if I had several of them, I could measure the magnetic field in 3 axes. And the wide range temperature will tell me, oh yes, you're going up, it's getting colder. Oh yes, you're going up, it's getting warmer. When you get high enough, it starts to get warmer. The stratosphere itself is not that cold, but there are cold regions on the way there. And then you'll come back down, and once you hit the ground, everything will typically level out because you won't be moving and you won't be changing your sensor values, your environmental conditions anymore. So that's what I got for Neulog sensors. Enjoy.